Before a system can be designed, before software can be developed, and before safety mechanisms can be implemented, one important question must be answered. What could go wrong? This question lies at the heart of the ISO 26262 concept phase. Part 3 introduces the activities that establish the foundation for functional safety. The objective is to understand potential hazards, assess risk, and define the safety objectives that will guide the remainder of development. In this video, we will explore the concept phase and understand why it is one of the most important parts of the entire standard. But before looking at the individual activities, let's first understand why this phase matters so much. The concept phase occurs very early in development. At this point, detailed designs may not yet exist. However, important decisions are already being made. The concept phase helps organizations understand potential risks before significant development effort begins. This allows safety considerations to influence the design from the start. Instead of reacting to problems later, the objective is to proactively identify hazards and establish safety objectives that guide the entire lifecycle. To understand how this is accomplished, let's look at the structure of Part 3. The concept phase consists of 3 major activities. The first activity is the item definition. The second activity is the hazard analysis and risk assessment, often called HARA. The third activity is the functional safety concept. These activities build upon each other. The item definition provides understanding of the system. The HARA identifies and evaluates hazards. And the functional safety concept defines how safety objectives will be achieved. Together, these activities establish the safety foundation for development. Everything starts with understanding the system itself. And that is exactly the purpose of the item definition. The concept phase begins with the item definition. The purpose of this activity is to understand the system being developed, its functionality, its boundaries, its interfaces, and its interactions with the surrounding environment. Before hazards can be identified, organizations must first understand what the system actually does. The item definition provides this understanding and establishes a common reference point for subsequent safety activities. Once the item is understood, the next logical question becomes, what could potentially go wrong? This is where the hazard analysis and risk assessment comes into play. The purpose of the HARA is to identify hazardous events and evaluate their associated risks. Several factors are considered during this activity, including severity, exposure, and controllability. The outcome helps determine the automotive safety integrity level, or ASIL. This process allows organizations to prioritize safety activities according to risk. But before discussing ASILs in more detail, we first need to understand an important concept. What exactly is a hazard? A hazard is a potential source of harm. Within ISO 26262, hazards are typically associated with malfunctioning behavior of a system. Not every malfunction creates a hazard, but certain malfunctions can lead to situations that may result in harm. Understanding these hazards is a critical step within the safety lifecycle, because they provide the starting point for risk assessment and safety planning. Once hazards have been identified, their associated risks can be evaluated, and this leads directly to ASIL determination. One of the most well-known outcomes of the HARA is ASIL determination. ASIL stands for Automotive Safety Integrity Level. The ASIL reflects the level of risk associated with a hazardous event. The determination is based on severity, exposure, and controllability. Higher risks typically lead to higher ASIL classifications. These classifications help determine the rigor required for subsequent safety activities. Once risks have been classified, the next question becomes, what must the system do to address these risks? Once hazardous events have been evaluated, safety goals can be defined. Safety goals describe the high-level safety objectives that must be achieved in order to address identified risks. They provide direction for future development activities, and they establish the link between hazard analysis and system design. Many later safety requirements can ultimately be traced back to these safety goals. The next challenge is determining how these safety goals can actually be achieved. And that brings us to the functional safety concept. The final major activity of the concept phase is the functional safety concept. The functional safety concept defines how safety goals will be achieved. It introduces high-level safety measures and functional safety requirements. These requirements will later be allocated to system elements during development. The functional safety concept therefore serves as an important bridge between safety analysis and technical implementation. Now that we have explored the major activities of the concept phase, let's summarize the key takeaways. The concept phase establishes the foundation for functional safety. It begins with understanding the item. It continues with hazard analysis and risk assessment. It defines ASIL, classifications, and safety goals. And it concludes with the functional safety concept. Together, these activities ensure that safety considerations influence development from the very beginning. This provides the basis for all later system, hardware, and software safety activities. If you want to go beyond this introduction to ISO 26262, we offer comprehensive online training programs on our website. These self-paced courses cover functional safety concepts, ISO 26262 requirements, practical implementation approaches, and real-world engineering applications. The focus is not only on understanding the standard, the focus is on applying it effectively in automotive development projects. You can find the link in the video description and also in the pinned comment below. If you found this video helpful, please consider giving it a like and subscribing to the channel. We regularly publish content on functional safety, ISO 26262, ASPICE, ISO 21434, and other engineering standards. Thank you for watching, and we look forward to seeing you in the next video.